Hello, I'm going to talk to you about the Western Interior Seaway today, or the ocean that covered Kansas millions of years ago. The Western Interior Seaway is also known as the Cretaceous Seaway because it was at its largest point during the Cretaceous period. It's also known as the Niobrarian or the North American Inland Sea. So it was a large inland sea that formed during the Cretaceous period around 145 million years ago. During the Mesozoic era, it expanded and contracted numerous times and then eventually grew to its largest point and covered most of North America. It was a result of continental plates pushing in from the sides of the continent and causing ridges and then leaving basins, and the basins then filled with water and led to this massive inland sea. Over time, the shallow sea made its way southward from up near the Arctic Ocean down through the continent until it then reached the Gulf of Mexico, or what is known as the Gulf of Mexico today. Um, After 50 million years of moving southward, the Western Interior Seaway had expanded to one of the greatest epicontinental seas of all times. It stretched from central Utah in the west to the western Appalachians in the east, and then in the north in the Arctic Ocean, all the way down to the Gulf of Mexico. An important part of this is its deposition of sediment that created a very strong fossil record associated with this period and also this geological feature, this inland sea. So the Western Inland Sea was formed 145 million years ago by these tectonic plate activities that created the ridges and basins to hold water. And as the tectonic plates lowered their angle of submission, so as they were at first subsiding under the other plate at a steep angle, creating these large ridges for water to hold water. As time went on, that angle lowered, then allowing the water to spread out more. So the water first took up more space, but as that tectonic activity continued, and things like the Rocky Mountains emerged, where you have this rising continent, the water then spread out and then made its way into the oceans, or what we know as the oceans today. Gradually, over millions of years and transformations of the global landscape, it moved southward and made its way into the Gulf of Mexico, and it carried with it a lot of sediment. So sediment was brought from other parts and carried by deltas into this large ocean, which contributed to the fact that it had a murky bottom, or a lot of mud. So if something died near this shallow ocean or shallow sea, it would then sink to the bottom, be held in this mud, and over time would then fossilize and would be preserved and then discovered later on by paleontologists, which is why we have such a broad knowledge of life that lived in this sea. So there was a lot of marine life. There were predatory marine reptiles, such as mosasaurs, which grew up to 18 meters long. There were ichthyosauruses and plesiosaurs, along with sharks. There was a shark called the Squalicorax, which had massive rose thorn-shaped teeth. It was 15 to 16 feet long, or 3 to 5 meters. Along with these marine animals, there were birds, as we define birds today, but they, weren't quite like modern birds. They had things like teeth. Some had wings, but they weren't for flying. They were made for swimming. For example, there was a flightless Hesperornis that had stout legs for swimming through water and small legs, or small wing-like appendages that it used for steering in the water while swimming rather than flying. Another interesting example of life that was found in this period is a giant clam called the Inoceramus, and it was found in the Pierre Shale fossil site. And paleontologists suggest that the giant size, being so big, was an adaptation that it came upon by living in these murky bottom waters. And because the waters were depleted of oxygen, they had to be large because the large gill area would allow them to breathe, even though there was very little oxygen in the water. A lot of this knowledge of life comes from the rock evidence that we've gathered over time. The Western Interior Seaway, it provided a lot of fossil evidence of ancient life because the murky waters and sediments. And along with that, it had the oxygen-depleted waters as a result of these muds that slowed decay and, let these dead organisms sit for a longer time and then create their impression in the mud and then contributed to a broad variety of fossils. As the sea spread out and then left, where Kansas is, for example, between 65 million and 23 million years ago, Kansas was left covered by sand, gravel, silt, and mortar beds, and those are, where we found those fossils. There's one example that I thought was really interesting, is that in Kansas there was this, I would call it a phenomena, that every 700 years there would be a half-inch layer of sediment that would be deposited, and then that would, contain these fossil records for every 700 years. And over time, those layers told us a great deal about, what life was like then, and also did a good job of dividing life into those periods so that we could see the evolution over time. The rock record specifically gave us a broad array of knowledge in dinosaurs, hydrocarbons, and coal. So first off, dinosaurs are an important part because they tell us so much about ancient life and how, life coped with the different geological, conditions of those ancient time periods. For example, most of North America was a swamp, or was, swampy, or was a sea because of the water levels. So life was obviously different during those time periods because, there's going to be more marine life because there's more water. And over time, life will change, but we focus on this short period where there's a sea there because that sea allowed more life to be, held in the fossil record and then able to be studied later on. It also told us about hydrocarbons and then about coal, which coal is a very important part because without coal we wouldn't have much of our electricity today because we have a strong reliance on coal. Differences in landscape and life at a time when the Midwest was mainly a low swampy area is clearly much different than we see today. You'd have fern trees, for example, which is much like a Jurassic Park image comes to mind. And I think that just studying the fossil record and then using that to make inferences about what life was like, 180 million years ago is a really important part of geology. Thank you.